Now we would like to prove some propositions on bipartite graphs. The first one is prove that a bipartite can contain no triangle. In other words, if there is a triangle in any graph, then it is not bipartite. How we are going to prove it? So this is the proof. Suppose we have a triangle. Suppose we have a triangle of 3 vertices A, B, and C. And we are going to draw it. This is A, and this is B, and this is C. So there is an edge between A and B. There is an edge between A and C. And there is an edge between B and C. So we will apply the pigeonhole principle. So N is equal to 3 vertices, and K is equal to 2 sets. And these sets, if you remember, V1 and V2. So by the pigeonhole principle, at least one set, either V1 or V2, contains, we apply the pigeonhole formula, pigeonhole principle formula. So 3 over 2 is equal to 2. So at least one set contains 2 or more vertices. So 2 or more, so minimum is 2. And since we have 2, and you know that every 2 vertices are adjacent, since every 2 vertices are adjacent and they belong to the same set and belong to the same set, then G is not bipartite, because 2 vertices adjacent in the same set, so this violates the definition for bipartite. Another way to prove it is, instead of pigeonhole principle, you can use coloring. So you say that since A and B are adjacent, so we will label A green and we will label B as red. Now for the third vertex, which color we should label it? If we label it green, then it will have a conflict with A, and if we label it with red, then it will have a conflict with B, and in both cases it will violate the definition for bipartite graph, and the graph is not bipartite.